Yeah, hi, and hello everyone. Is my audio audible to you guys? Can any of you just confirm once?
Yes, sir, you are audible.
Yeah, okay, thanks very much. We'll just start in just a while. I'll just hang on for around 4 or 5 minutes and then we can go ahead, okay? So, yeah, thanks for joining, and we will just start in 4 or 5 minutes. Yeah, can you tell if my screen is visible to you?
Yes, sir, screen is visible.
Okay, okay. Okay, so I think we can start now. It's, I think, 5 minutes past 6. Yeah, so welcome every one of you to this tutorial session for the course on Introduction to Electrical Engineering. So, as you know, the course instructor is Professor Bhim Singh from IIT Delhi, and I am the teaching assistant for this course. I am PT Nandkishore. I am a PhD candidate in the Department of Electrical Engineering, IIT Delhi. Okay. So throughout the course, we will actually be having a set of problems that need to be definitely solved. So for today's session, we are having around 19 problems that we have to solve, right? And after that, if time permits, we can see additional problems. Okay, if time permits. Fine. So I think we will just start off now. Um, okay. So this week one was your introductory lectures towards this course on electrical engineering. So you had a few introductory lectures that talked about where electrical engineering is being used and where in particular networks are useful for you guys, right? And if you're doing your BTech first year, or if you're in your undergrad, you will see that you have to have a very solid foundation about network theory, right? So any course that you would take up in your, let's say, second or third year, or even in your master's or PhD, whatever you do, you will be seeing that every network or every electrical circuit can be solved using a set of theorems or set of rules that you would have learned in your basic electrical engineering, right? So it's important that you practice all these problems and internalize it. Okay. So yeah, in the first week you went through Kirchhoff's laws, that is KCL and KVL. You learned about mesh analysis, nodal analysis, and about source transformations, right? That is voltage and current source, their properties, and how do you convert voltage to current and vice versa, right? And you also learned about star to delta and delta to star transformation, right? And finally, before the week concluded, you learned about three theorems. One is the superposition theorem, right, based on the principle of linearity and homogeneity. And then you learned about the Thevenin's and Norton's theorems, which actually help you simplify any particular network, right? If you're given a complex network, these theorems help you simplify the entire network into a voltage source in series with a resistance, or a current source in parallel with a resistance again, right? So you learned about how to find out the equivalent voltage or current source. And then finally, you learned about the theorem of maximum power transfer, right? Which is again based on Thevenin's theorem. Okay. So in the theorem of maximum power transfer, what you do is that you kind of find out the Thevenin equivalent of the circuit, and then you put the required RL or the load resistance, and you find out for what particular or for what value of RL you will be able to transfer maximum power, right? So this is something you learned. So we will be seeing problems in pretty much all of these topics today. Okay. Fine. So yeah, and I would advise you to take out your calculators. Okay. If you have a scientific calculator, that would be great. So without calculator, you may not be able to do today's session or any session, right? So better all of you take out your calculators. Okay. So the first question is the charge that has entered the terminal of an element from t equal to 0 to t equal to 3 seconds when the current entering the element is as shown in figure below is dash coulombs. Okay, so the current versus time profile is given. They have asked what is the charge, right? So they have asked what is your Q. Okay, so I think this is pretty much simple for you guys. You would actually know that basically your current is I is equal to dq over dt. Therefore, you may write Q to be integral I of t dt, right? Okay. So over here, your t varies from 0 to 3. Okay. And then you have to find out what is a function I of t. Okay. So this will pretty much give you the answer, but there are two ways to go about this, right? So one is you do the integral way, right? That is, you write the line equations for each of these segments in the curve, and you integrate it between the limits and find out what is the charge. Or you already know that the charge is basically the area under your time versus current curve, right? That is this particular area. Okay. So the simpler way would be area is what? So let's divide this into segments. Okay. So if we kind of divide this into segments, we have segment A and then segment B. Okay. So what about segment A? You see that the area in segment A is simple, right? It's just a square, which is 1 into 1. Plus what about segment B? you see that in segment B, you get a geometry something like this. Okay. So what would be the area of that? So the area can be written as something like this area plus this area. Okay. A square and a rectangle and a triangle. Okay. So you can write the area to be. So what would be the area of the rectangle? It would be 3 minus 1. Okay. 3 minus 1 into 1. Okay. Plus area of the triangle, which is half into base into height, that is half into bases 3 minus 1 into the height is again 3 minus 1. Okay. So you get 1 plus 2 plus 2, right? 5 coulombs. All right. Yeah, 5 coulombs. Okay. So this is the charge that is that has entered the terminal of an element given the current profile shown over here. Okay. So just we have found out the area under the curve. Simple, right? The other way, the lengthier way would be you doing the actual integration, right? By integration. Okay. So you first have to find out the line equation by integration of the line equations, right? So this is a line equation. You have to find out the line equation of this straight line and this line, and then you put it under u is equal to integral I of t dt. Okay. So you can integrate it, get the answer, or you can just find out the area under the curve. Area, you know, is a direct representation of the integration function. Okay. So I think this question was pretty much straightforward. Okay, just we found out the area under the curve. Okay. So if this is fine, we can go ahead with the next question. Right? Okay. The equivalent current source using source transformation for the shown figure below is dash. Okay. So a figure is shown. They have asked what would be the equivalent current source. Okay. Yeah. So again, this is a very simple question. So you look from this terminal, right? You look from this terminal, find out what is the V equivalent or V Thevenin. So you see that if you just apply a simple KVL, right? So what you get is, so just take the independent sources that are over here. So you get 6 volts plus 20 volts and minus, yeah, and minus 10 volts, right? So which gives you 16 volts. So this is your V equivalent, and you know the R equivalent, seeing from this terminal, is going to be just a summation, right? Because the resistors are in series. So 1 plus 2 plus 5, which is 8 ohms. Okay. Therefore, the equivalent current is going to be simply V equivalent by R equivalent, which is 16 over 8, that is 2 amperes. Okay. Again, I think this is a very simple problem. Yeah. Just hang on a second. Okay. Yeah. So if this is fine, we can go ahead with the next problem, right? Yeah. So the equivalent resistance parallel to the current source using source transformation. So what is the answer for this question? Can you tell? This is again a straightforward question, same question only. Can you tell what is the answer for this?
8 ohm.
Yeah. So this is 8 ohms. I think we need not spend any time on this. Okay. So the next question is again, there is a simple question. The value of the node voltage V in figure below is what? So sorry. So what is the value of V is the question. All right. So what you
12
do?
volt.
Yeah, correct.
12,
So
12 volt.
2 amperes going over here and 8 amperes going over here. So what is, yeah, so again, this is the catch over here. You need to specify the sign also. Okay. So 2 amperes going over here, 8 amperes going over here. Obviously, it means that 6 amps going from bottom to top, right? So if you see the voltage drop, it's in the opposite direction. So the V is actually minus 6 into 2 ohms, which is minus 12 volts. Okay. In the final exam, you may have to fill in the blanks. Okay. In that case, please do not forget the negative sign. All right. Yeah. So this is by simple KCL that we obtained the answer, right? Okay. Yeah. So we go ahead with the next question. That is 200 watt, 220 volt bulbs are required to be connected across a 400 volt supply. The value of the resistance to be inserted in the line so that the voltage across the bulbs do not exceed 220 volts is dash. Yeah. So what they have given is you have a 400 volt supply, all right? So you are having a 400 volt supply, and um, they have told that you have two bulbs, okay? So you have two bulbs to be connected across, right? Sorry. So you have two bulbs to be connected across, which means that the bulbs are actually in parallel, all right? Across a 400 volt supply, the value of the resistance to be inserted in the line so that voltage does not exceed 220 volts, which means that apparently there is some resistance that you need to insert in the line, okay? And what is this resistance going to do? This resistance actually makes sure that the voltage across your bulb is not going to exceed 220 volts. Okay. So you can understand that if let's say there was no resistance over here, right? If I directly connect this, the voltage across the bulb is going to be 400 volts. Correct? If I do not connect, if I do not have any dropping element, you see that the voltage across the bulbs is actually going to be what? It's actually going to be 400 volts. The question they are asking is that what is the value of the resistance that I need to insert into the circuit, right? I have to insert some resistance into the circuit, right? So that some drop happens across it. So what is this resistance? So that my final voltage across the bulbs is going to be only 220 volts. All right. So this is the question. Okay. And the point is now they have given what is the wattage of the bulb and what is the volt rating of the bulb. From this, we can find out what is the resistance, right? What is the resistance of the bulb? Okay. First, we have to find out this. Only then we can go ahead with the next step, right? So, yeah. So since, sorry, you know that P is equal to V square over R. Therefore, R is equal to V square over P. Okay. So R bulb will be what? V bulb, the whole square divided by P. Right? So V bulb is given as 220 volt and divided by P is 100 watts. Right? So you should be getting around 484 ohms. Correct?
Yes.
Yeah, 484 ohms. Okay. So now what we are going to do is, right? Now what we are going to do is, we are going to replace the bulbs in the circuit with their equivalent resistance. Okay. So this is the R to be found out. And you had two bulbs in parallel, right? And each of the bulb is 484 ohms. Okay. Okay. They have also given that the voltage across the bulb is actually going to be only 220 volts. Correct? Now we have to find out what is the value of R that makes this possible. Basically, this is just a potential divider circuit, right? So just simplify this. So we have 400 volts over here, then a resistance over here, and then we have another resistance, all right? The voltage is 220 volts. The equivalent resistance is going to be 484 by 2, which is 242 ohms. All right. Now this is, I think, very simple. So you know that since this is just a potential divider, 220 is equal to 400 into 242 divided by 242 plus R. Right? This is just a potential divider circuit.
Mm,
Therefore, you can just simplify this and you get what is R, right? What is the value of R that you will be getting? 242 by 220. Yeah, I think you will get 198 ohms. All right. Okay.
Okay, sir.
Okay. Fine. So we'll go to the next question. Yeah, again a very again a very simple question, that is find the value of VA minus VB, right? So VA minus VB is what we want, and the current of 2 amperes is flowing over here. So directly apply KVL. You will be getting 2 into 3, right? Plus 2 plus 2 into 1, right? Which is 6 plus 2 plus 2, which is 10 volt, right? Very straightforward question. Okay. Okay. So I think this is also straightforward. We'll go to the next question. So the question is, a utility company Charges
Sir, in
6.8.
previous question, negative, it will be negative or positive?
So the question is VA minus VB, right?
So
So
current
2
is
ampere
flowing
going over
from
here.
A, so this will be
Correct.
positive, yes.
This is 2 into 3 positive. Then this is also positive. This is also positive. So the polarities would be adding up, right? Right?
So overall voltage will be positive.
Correct. Okay.
Okay, sir. Clear. Move ahead.
Sorry? Clear, right?
Clear,
This is
sir.
fine, right? Okay. So, as I was telling, the next question is a little bit different. Okay. So the question is, a utility company charges rupees 6.8 per kilowatt hour. Okay. If a consumer operates a 60-watt light bulb continuously for 1 day, the consumer is charged how much rupees? Okay. So, they have given you the total charge per kilowatt hour. Okay. By the way, kilowatt hour is a measure of the energy, right? Energy is generally written in kilowatt hour, right? So you know energy is power into time. So power is expressed in watts and time is expressed in seconds. So this is the SI unit. But in practice, we do not represent it as watt second. We represent in kilowatt hour. Okay, fine. So what I've given is that so we generally call 1 kWh is 1 unit, right? So at home also or anywhere, we generally tell how much power is consumed or how much energy is consumed in units, right? So this is basically 1 unit. So basically they have given you the unit cost, right? So 1 unit is costing you rupees 6.8. Okay. Yeah. So they have given that a 60-watt light bulb is operating for 1 day. All right. So the power is 60 watts and operating for 1 day. The time is 1 day, which is 24 hours. Okay. So therefore, what is the total energy? Energy is going to be power into time, which is going to be 60 into 24, which is going to be how much?
1440. 1414.
Correct. 1440 watt hour, or I can write this in kilowatt hour as 1.44 kilowatt hour. All right. So if you operate a 60-watt bulb for 1 day, this is the energy that is actually getting consumed. Okay, 1.44 kilowatt hour. So they have given that 1 kilowatt hour actually costs you 6.8. So 1.44 kilowatt hour will cost you how much? 1.44 into 6.8, which is going to be
9.792.
correct. Rupees 9.792. Okay, fine. So this is based on the energy. Okay, they have given you the power and it's operating for 1 day. You calculate what is the kilowatt hour and they have given you the cost for 1 unit, right? 6.8 rupees. So you can find out for how much energy for your energy consumed, how much will be the cost. All right. Right. We can go ahead with the next question then. Okay. So this question is, using superposition theorem, the voltage across 5 ohm resistance marked as V naught for the circuit shown in figure below is dash volt. Okay. So from now on, the questions you would see are not that straightforward. So please pay attention and take out your calculators, everyone. Okay. So basically, you would have learned about superposition theorem, right? So in superposition theorem, if you have, let's say, two independent sources, what you do is you disable one source and you see what is the effect of just one active source in the circuit, right? And so you will, let's say you get the answer as y, you keep that as y1. And what you do is now you will enable the other source and disable the source that you had enabled in the previous iteration, right? So due to one independent source, you will see what is the effect on the circuit. Let's say the parameter that you are seeing is now y2. So what you tell is that the final solution for y is going to be y1 plus y2. All right. And this is not just applicable for just, let's say, one source. If you have a n number of sources, what you will do is every time you will disable all other sources, just keep one source active and find out the effect on the circuit and do this for all the n sources. Okay, that is basically superposition. Okay, so the question is, using superposition theorem, the voltage across the 5 ohm resistance, right? That is this particular resistance. Okay, the 5 ohm resistance is how much? That is V naught. Okay, note that in this circuit you are having two independent sources and there is also a dependent voltage source which is 6I, right? I is the current flowing through this 3 ohm resistor. Observe over here, there is a current flowing through this 3 ohm resistor. Okay, so can any of you tell, like, we told that we can disable independent sources, keep only one source active and see the effect on the circuit. So should or can I disable the dependent voltage source or no?
No, I cannot disable the dependent sources.
Correct. So you can only disable 28, you can only disable 18. 6i will always be there in your circuit no matter what. Okay. Sorry, I'm not well. So okay. So what we will do is first let's okay. So in case A or case 1, what we will do is let's disable the 28 volt source. Okay. Keep 18 volt active. Okay. So we will be getting a value for V naught. Let's call this V naught 1. Okay. In the second iteration, we will disable, sorry, we will disable the 18 volt source and keep 28 volt active. The value for V naught that we will be getting is V naught 2. So the final answer is going to be what? V naught equal to V naught 1 plus V naught 2. Okay. By superposition. Okay. All right. Okay. First section, we're supposed to disable 28 volts, right? So let's disable. Am I still there? Yeah, okay. Okay. So if I disable the 28-volt source, right? So what I'm going to have is 5 ohms over here, and across this I will be having what is V01. Okay, and they have given that this is current I, right? This is your 3 ohm resistor. Okay, we have disabled 28 volt. If you say that you are disabling a source, voltage sources, voltage source is shorted or opened. If you
Shorted.
disable it, correct.
Voltage
So
source
voltage
shorted,
source is
current
shorted,
source open circuit.
current source is opened. Okay. Okay. So since my 28 volt is shorted, I am directly drawing 6 ohm in parallel with 3 ohm. Okay. So 6 ohm in parallel with 3 ohm, and then you are having a 12 ohm and 4 ohm. Okay. So this is your this is your 12 ohm, and this is your 4 ohm. You are having a voltage source over here which is 18 volt. And you are having the dependent voltage source over here. You cannot do anything to this, right? So this, the value is actually 6i. Okay. Okay. So let's start simplifying, right? So the point is, you can obviously see that 6 ohm and 3 ohm are in parallel, right? But you cannot directly just simplify this. You have to bear in mind what would happen to current I. Okay. So if current I flows through 3 ohm, right? What would be the current through 6 ohm resistor? You imagine this, okay? Let's say through 10 ohm, okay? Let's say through 10 ohms, I'm able to flow 10 ampere of current, okay? Let's say I'm just taking an imaginary case, okay? Through 10 ohm, I am flowing 10 ampere of current for the same potential difference, okay? Now for the same potential difference, right? Let's say I have 20 ohms. What will be the current magnitude?
5 ampere.
5 ampere. So what happens to the current? Current basically becomes half, right? Current becomes half. So by the same analogy, can you tell what will be the current flowing through 6 ohm?
I by 2.
So the current through 3
I
ohm
by 2.
is I. Yes.
I
So
by
current through 6 ohm will be I by 2. Okay. Okay. So from this node, you see that as far as current I is concerned, right? There is I by 2 going over here. There is I going over here. Now, if I simplify this 6 ohm and 3 ohm into a single resistance, all right, that is what I draw is, I'm just simplifying this, right? So I have a single resistance, right? 6 parallel to 3 is basically 2 ohms, correct? 6 into 3 by 6 plus 3, okay? 2 ohms. And I keep the rest of the circuit same now. Okay. So can you tell what will be the current that is flowing through 2 ohm resistor? See, I simplified 6 ohm and 3 ohm into 2 ohm. 6 parallel to 3 is 2. Okay. You also told that there is a current I flowing over here, and through 6 ohm there is I by 2. So what will be the current that will flow through the 2 ohm resistor?
I.
See, through 3 ohm, I am able to
3I
flow
by 2.
3. Correct. So through 3 ohm I am flowing I, and through 6 ohm I am flowing I by 2. Okay. So the total current will obviously remain same if I put it into a single resistor. The total current is going to remain same, right? So the total current is going to be what? 3I by 2. Why? Total current is basically I plus I by 2, which is 3I by 2. Okay, right? So 3I by 2 will be the current that is flowing through the 2 ohm resistor. Is this understood by every one of you?
Yes, sir.
Clear, right? I mean, how 3I by 2 we are able to get? Okay,
Yes, sir. Clear.
okay, fine. So just erase this stuff off. So now we can go ahead and apply our usual mesh analysis, right? So just consider 3 currents for our case. Let's call this as I1, all right? And this as I2, and this as I3. Okay, we have 3 currents, 3 loops. So it should be just a system of 3 equations with 3 unknowns, which can be easily solved. Okay. So for mesh 1, what can you write? 18 is equal to 4I1 plus 12 into I1 minus I2, right? Which is 16 I1 minus 12 I2. Okay, this is one. In the next mesh, you're having, so let's call this mesh A, mesh B, and mesh C. So this is for A. For B, you see that there is no active source over here, so you can write directly 0 is equal to, all right? So I can write 2I2 through the 2 ohm resistor plus 12 into I2 minus I1, right? Plus 5 into I2 minus I3, all right? So it's going to give me minus 12 I1 plus 19 I2 minus 5 I3. Okay, is this clear? How we get equation? Anyone have any doubt? Please let me. Clear?
Yes, sir. Clear.
Everyone else, is it clear?
Yes, sir.
Clear, right? Okay. So if this is fine, we can go to mesh C,
Sir,
right?
sir,
Yeah.
we know that value of across 2 ohm resistance 3I by 2. Can I put this value?
Yeah, very much, very well, very well. Yeah, yeah, you can do that. We will anyway be doing that, yeah. Okay. So
Sir, can I replace I2 by I2 to 3I by 2?
yes, you can do that. We will be doing that, yeah, anyway. Just hang on. So in Met C, right? So you are having a voltage source, sorry, 6. Let's see, you are having a voltage source 6I, right? So you get basically 6I is equal to 5 into I3 minus I2. All right. So you know that basically your I2 is going to be what? I2 is going to be 3I by 2. We just saw over here, right? This is the current that is flowing through the 2 ohm resistor, which is the same as I2. Okay. So you can replace I in the above equation to be 2I2 by 3. Okay. Therefore, your equation becomes 4I2 is equal to 5 by 3 minus 5 by 2, or 0 is equal to minus 9 plus 5 by 3. Fine. So anyone has any doubts or confusion as to how we wrote this? Do you want me to explain once again? Please do let me know. I will just stop over here for once. Please do let me know if you have any doubts. Okay. If you cannot unmute, if you put it in the chat box, I will just hang on. Okay. Is this fine with everyone? All the mesh equations are fine, right? Okay. So if this is fine, we will go ahead and solve the equations. Okay. The equations 1, 2, and 3 need to be solved. And we will find out what is the value, what are the values of I1, I2, and I3. Okay.
Hello, sir.
Yeah.
Sir, what is exactly the application of nodal and mesh analysis?
What is the application of nodal and mesh analysis?
Hmm?
So you're asking like, why are we doing all of this stuff over here, right?
No. I'm asking you where it can be applicable. Means nodal and mesh analysis, applied nodal and mesh analysis.
So, if are you a BTech student, like in first year or something?
Nah, I'm from instrumentation and control department.
Okay.
I'm faculty over there.
Okay.
And I'm from instrumentation and control engineering department.
Okay. So, you are asking the applications of the nodal and mesh analysis, right? So I will take an example for, let's say, analog circuits, right? If you go through analog circuits, you will be having a lot of op-amp based circuits or BJT based circuits, right? So in all such cases, we have to use, we will be using nodal or mesh analysis, right? So let's say, for instance, right, if you want to design a voltage to current converter using op-amp, right, or vice versa, current to voltage converter, transconductance amplifier, or instrumentation amplifiers, right? All of these analog circuits, the basic heart, if you have to solve them, it will boil down to nodal and mesh analysis only.
Okay.
Or let's say you have BJT based circuits, right? You would have heard about current mirror circuits, right? Where we want to create a constant current source or current sink, right? So in all of those circuits also, we will be requiring nodal and mesh analysis. This is coming in the top of my mind, but you have a lot of circuits. If you go to, let's say, power electronics applications, right? So over there also, you'll be realizing a lot of converters, and we will basically be boiling down the entire circuit, be using nodal and mesh analysis only. So it has a lot of applications, I would tell.
Okay, sir. Okay.
Okay, so I hope this is clear to everyone. That is, how do we arrive at the mesh equation? Okay, main thing is you will obviously be doing the mesh analysis, but the point is how do you link the dependent source, right? That is I with any of your current expressions, I1, I2, or I3. Okay, over here we found out the equivalent current, right? That is flowing through the equivalent resistor. So I amount of current is flowing through 3 ohm. So you obviously know that I by 2 is the current flowing through 6 ohm, right? So the total current that would be flowing will be I plus I by 2, that is 3I by 2 through the equivalent resistance. Okay, and you know that 3I by 2 is basically the same as your current I2. Okay, fine. So we have got three equations now, right? So we have got 3 equations and 3 unknowns, right? So just solve all of this. Has anyone solved, or should I have to solve? So you got 18 is equal to 16I1 minus 12I2. 0 is equal to minus 12I1 plus 19I2 minus 5I3. And you got 0 is equal to minus 9I2 plus 5I3. Okay, so turns out that if you solve this, you are going to get I1 equal to 11.25 amperes, I2 is equal to 13.5 amperes, and I3 is equal to 24.3 amperes. Okay. Okay, so we have got I1, I2, and I3. So from this circuit, can you tell what is my VO1? What is the expression for VO1? What is the expression for VO1? So what is VO1?
VO1 equals to 5 times I2 minus I3.
Correct. So 5 times I2 minus I3 is VO1, right? So see the circuit over here. So yeah, no, but based on the polarity that we have considered, it would be VO1 will be 5 into I3 minus I2, right? So I3 is coming like this and I2 is coming like this. So based on the polarity that we have considered, the VO1 will be 5 into I3 minus I2. Am I right? Correct?
Yes, sir.
Okay. So VO1 is going to be 5 into I3 minus I2, which means 5 into 24.3 minus 13.5, and let's do calculator. 24.3 minus 13.5 into 4, which is 54 volt. Okay, so this is the voltage across a 5 ohm resistor with only 18 volt source and 28 volt source shorted, right? So we will go back to the circuit that we were talking about, right? So 28 volt was shorted and 18 volt was the only active source. Now the next part of the circuit will be disable the 18 volt source and enable 28 volt source, right? So that will be the next question that we need to do. Okay. So this was part 1, right? So now we will go ahead with part 2. Part 2, where we will disable the 18-volt source and enable the 28-volt source. Okay. So if I go back to the circuit, so 18-volt is disabled, all right, and 28-volt is enabled. So this is going to be what? It was 6 ohm. And this is 3 ohm. The current is I. This is 5 ohm. This will be VO2. All right. And this is 6I. And this will be how much? This was 12 ohm and 4 ohm. 18-volt is disabled, therefore 18-volt will be shorted. So 12 and 4 are in parallel. Okay. So this is 12 ohm and this is 4 ohm. Right? 18-volt is shorted and 28-volt is only there. Okay. Okay. So what is the equivalent of 12 parallel to 4? What is the equivalent of 12 parallel to 4? 12 into 4 by 12 plus 4, which is equal
3
to
ohms.
3 ohms. So what I am going to do is, I will, for simplicity, what I will do is I will directly replace this by, okay, or let it be, we'll go to the next page. 12 ohm. This is 4 ohm. Okay, so yeah. VO2. So we told that 12 parallel to 4 is going to be 3 ohms, right? And this is going to be 6I. Okay. So this is even simpler problem. All right. So just have 3 currents. So let's call this I1, I2, and whatever you take as the direction of current, let's call this as I3. Okay. Okay, let me simplify this. Let's call this as I3. Okay. So what will be the value of VO2? What is VO2 from this diagram? VO2 will be 5 into polarity is like this, plus minus. So
I2
plus
minus
to minus.
I3.
Correct. So VO2 is going to be 5 into I2 minus I3. We just need to find out what is I2 and I3. Okay. So just write the expressions once again. 28 in mesh A, right? Mesh A, B, C. So 28 is equal to 6I1 plus 3 into I1 minus I2, right? Which is 9I1 minus 3I2. and there is no source in the second mesh, so you can directly write 0 is equal to 3i2, correct? I started over here, okay? So 3i2 plus 3 into i2 minus i1 plus 5 into i2 minus i3, which gives you minus 3i1 plus 11i2 minus 5i3. Okay, and finally you have oh, so finally you have 0 is equal to 6i, right? 6i plus 5 into i3 minus i2. All right. Okay. So again we have yeah. So again we have the variable I, right? And of course we have I1, I2, and I3. So we have to relate I with I1 or I2 or I3. Okay. So what is the relation over here? Can you tell what is the relation between I and I1, I2, I3? From this diagram, can you tell? See, the current I is flowing over here, right? The current I is flowing over here. Okay. So this is my I. From here, what can I tell? I is basically what? I1 minus I2.
I1
correct?
minus I2.
Correct? Right. So this is what we will be actually substituting over here. So 6 into I1 minus I2 plus 5 into I3 minus I2, which means that 6i1 and minus 11i2 plus 5i3. Okay, so solve 4, 5, and 6. Solve 4, 5, 6. You should be getting what is I1, I2, I3. Can you tell? Can anyone tell what is I1, I2, I3? What is I1, I2, I3?
So I have solved, but my directionals are different.
Okay, no worries. You can tell me the absolute value also. What is I1? Or I can also solve this. So what you will be getting is I1 equal to 0 and I2 equal to minus 9.33 and I3 is equal to minus 20.533. Is this understood by everyone how we are writing the mesh equation? Do you have any doubts in the mesh equation? If you have any doubts, please let me know now. Fine. Okay. So again, now that we have got I1, I2, I3, we will go ahead and substitute in this expression, that is VO2, right? VO2 is 5 into I2 minus I3. Okay. So VO2 is 5 into I2 minus I3, which is 5 into I2 is 5 into minus 9.333, and I3 is minus 20, so minus of minus is plus 20.533, right? So what is the value that you will be getting?
So 56.
Correct. So you should get 56 volts. Therefore, by superposition, total V0 is going to be VO1 plus VO2, right? So I think we got 54 volts in the first case where we disabled the 28 volt source. And in the second case, we got 56 volt. Therefore, the total V0 is 110 volts. Okay. Yeah, the
Yes,
voltage
sir.
that we were looking for, it is 110 volt. Did you get how we did it, everyone? That is, one is we applied superposition, but even after applying superposition, you have to make sure that you relate the current I or the parameter I with your whatever equations that you're doing with I1, I2, I3 in this case, because we apply mesh analysis. Okay. So you have to kind of relate I with your I1, I2, I3. Okay. We did mesh analysis. Similarly, if you did nodal analysis, again, you have to relate your I with whatever voltages you will be assuming. Okay. Right. So here, this is the relation, right? That is, we related I with I2 in this case, in part one case. In second case also, we were able to relate I is equal to I1 minus I2, something like this. Okay, this is very, very important. Okay, only then you will be able to solve the mesh equations, or else you will not, you will not be able to solve it. Okay, fine. Is this fine with everyone? If this is fine, we can go ahead with the next problem.
Yes, sir. Understood very well.
Okay, good. We'll go ahead then. Okay, so we'll go to the next question. This is simple. The Norton current across terminal AB for the circuit shown in figure is dash ampere. So what is the answer for this question?
1 ampere.
No, how can you forget the existence of this? So how will you solve this question?
Find Norton's current across A and B.
Correct. So you will find out Norton's current. That is fine. So to find out Norton's current, what will you do? What is the procedure that you would follow?
Define Thevenin resistance and current. Wait, the Thevenin circuit.
Okay. So you will define Thevenin's resistance and then
We will find the current through the dead circuit, Thevenin equivalent circuit. Yeah, Norton equivalent circuit.
correct. Okay, so so should I solve this or can you guys try to do this on your own? So the answer will be 1 plus something. So this is already there, right? So the final answer will be 1 plus something. You just need to find out this answer. Then the answer will be done. And you will know that this 10 volt source is actually going to play some role. Right? So how do you find out? Okay, so we'll just solve this. So I can kind of redraw this circuit as something like 10 volt, 15 ohm, and what I will have is this is 1 ampere. Okay, so this is 25 ohms. All right. So you obviously know that this 1 ampere is actually going to flow through only this 25 ohms. Okay. And again, there is going to be a current over here. Right. So this and this together is one source. Okay. So then in that case, what you are left with is just this, right? 10 and 15. So can you tell me what will be the current equivalent current source for 10 and 15? What is the equivalent for 10 and 15?
10 by 15 ampere.
Correct. 10 by 15 amperes. So the final answer is going to be simple. 1 plus 10 by 15. 1 plus 2 by 3, which is 1.667 amperes. Okay, simple, right? Consider this together as one pair, right? So what you are left with is just
The voice is not coming from your side.
Yeah, hi. So now are you guys able to hear me?
Yes, sir, you are audible.
Okay, okay. Thank you. Okay. So we were just doing this, right? That is, I told you that the equivalent Thevenin resistance, in case you are having both dependent and independent sources, would be VOC by ISC. That is V open circuit voltage divided by the short circuit current. Okay. So you will open up the terminals, you will short the terminals, you will see what is the voltage and current respectively, right? So a division of both of these will give you the Thevenin resistance. Okay. That's what we are doing over here. That is, first we will find out what is VOC. Okay. So what is VOC? Um, so what will be VOC? VOC is what you will see from this terminal, right? So just we apply KVL over here through the loop that is shown in dotted line, right? So 10 is equal to what? 5 into Ix plus 10 ohm into what is the current through the 10 ohm resistor? This current is going to be 3Ix, right? Because Ix is coming over here, 2Ix coming over here, the total summation is going to be 3Ix, right? So 10 into 3Ix, all right? So you get 5Ix plus 30Ix, which is going to be 35Ix. All right. So your Ix is going to be what? 10 by 35, 2 by 7, which is how much? Somewhere around 0.28, right? Yeah. So 0.2857 amperes is your Ix. Okay. So what is your VOC? Now that we have found out what is Ix, what is your VOC? VOC is what? VOC is the voltage across the 10 ohm resistor, right? So 10 into the current is 3 times Ix. So 10 into 3Ix, which is 30Ix, right? So 30 into 0.2857, right? 8.571 volt. Okay. This is your VOC and this is also your Thevenin voltage. Did you guys get this question? How did we find out VOC? Is this fine? Or is my voice still gone again? Are you able to hear me, everyone?
Yes,
Yes,
sir.
sir.
Okay, okay. So, did you understand how we got VOC?
Yes.
It is,
Yes, sir.
yeah, this is this direct KVL, right? So now that we have got
Excuse me, sir. Again, your voice is not audible.
yeah, hi, sorry for the interruption, but now is it fine? Is my voice fine?
Yes, sir. Voice is
Yes,
fine.
sir.
Okay. I don't know, sometimes it's happening. I'm not really sure why. Okay. Okay, so we will continue from here, right? So we have to find out what is ISC. Okay. So to find out what is ISC, we basically short the terminals where we want to find out ISC. Correct? So the current that will flow through this is basically ISC. Okay. So now that we have shorted this ISC, will 10 ohm play any role, or can I remove 10 ohm directly? So can I remove 10 ohms? Or am I gone again? Hello?
Yes, sir. Voice is clear. We cannot remove 10 ohm resistance.
Okay, so you tell me something. Let's say you have a resistor and then you short it like this. So what is the equivalent resistance?
Okay, sir. Yes, we remove with 10 ohm resistance.
Correct. So you can directly remove your 10 ohm resistance. Okay. So 10 ohm is now out of the picture, right? So if I can draw the equivalent network, your network is going to be basically 10 volt, 5 ohm, Ix flowing over here, and then 2Ix coming like this, and then you have a direct short. This is ISC. Okay. So can you tell what is ISC in terms of Ix? What is ISC in terms of Ix?
3ix.
Correct. So your ISC is basically 3Ix. This is 1. And just apply KVL over here. What will you get? 10 is equal to 5Ix, and then there is nothing, right? So basically your Ix is equal to 2 amperes. Therefore, your ISC is equal to 3Ix, or 3 into 2, that is 6 amperes. This is your short circuit current. Okay. So your short circuit current is 6 amperes, right? So in the previous slide, we got the open circuit voltage 8.57 volt, and here we have got the short circuit current, that is 6 ampere. Therefore, your R Thevenin is what? V open circuit by I short circuit, right? That is 8.57 volt divided by 6 ampere. How much are you getting? How much are you getting? I think you should get around 1.429 ohm. Is this fine with everyone? How we found out the R Thevenin for a circuit having both dependent and independent sources? We find out what is VOC by ISC. Okay, we open the source, we open the terminals, find out the equivalent Thevenin voltage, we short the terminals, we found out the equivalent current. So this current is also called as what current? Open circuit voltage was the same as Thevenin voltage. So this current is what? What is this current? Okay, this is Norton's current. Fine. So basically, you found out what is R Thevenin, right? VOC by ISC. Is this fine with you guys? Is the question clear? How we solve the question? VOC by ISC was our answer. Okay.
Yes, sir.
So
Clear.
the next question is the Thevenin voltage for the circuit shown in figure. It's the same circuit they have asked the Thevenin voltage, right? Which is the same as open circuit voltage. We found out the open circuit voltage is how much? 8.57 volt. Correct? We already found this out, right? So the answer is 8.57 volt. Okay. Yeah. So VOC, ISC, correct. Yeah. So it is 8.57 volt. Okay. So I'm moving to the next question, right? Okay. So the value of Thevenin equivalent resistance of the circuit shown in figure is dash. Yeah. So can you try to tell what is the value? Thevenin equivalent resistance.
Six ohm.
Sorry, 6, right?
RTH equals 6 ohm.
Right, right. So how did you do? So how do you do this?
3 ohm and 6 ohm in the parallel and 4 ohm in the series.
Correct. So first, yes, you're right. So in order to do that, what we do? We disable the voltage. We disable the voltage source, which means we short it, and we open up the current source, which means that we open circuit it, right? So the equivalent circuit becomes 3 ohm in parallel with 6 ohm, correct? And there is no current source and there is a single 4 ohm, right? So 3 parallel to 6 is 2 and in series with 4, it gives you 6 ohms. Straightforward, right? Is this fine with everyone? Is this
Yes, sir.
fine?
Yes, sir.
Okay, it's very simple compared to what we did in the previous problems. So obviously the next question is what is the value of the Thevenin voltage, right? So how will you do this? Thevenin voltage? Simple, just do mesh analysis. Let's call this I1 and let's call this I2, right? Just write mesh equations. Okay, I will take this I1, I2. So just write mesh equation. This is very simple problem. 3I1 plus 6 into I1 minus I2, which means 9I1 minus 6I2. This is one expression. second expression is going to be what? Second expression? Yeah, so how will you write your second expression?
I2 is equal to 6 ampere.
I2 is equal to 6 ampere.
6I2 minus 6I1.
6I2 minus 6I1 is equal to what?
0.
So how are you completing the loop?
Oh, equal to 6. Okay.
No, you tell me how you will complete the loop. So see, there has to be a completion of the loop, right? So how are you completing the loop?
I don't know. Please tell me.
Yeah, okay. So just just give 2 minutes and think, okay? I'm just give me 2 minutes. You also think for 2 minutes, okay? I'm just have some water and come. Okay? This is a good question, right? So how do you complete the loop is the question, right?
6 ampere in the outer side. So in this loop, only flow 6 ampere current.
Correct. So what is I2? What is the value of I2?
6
I2
ampere.
is,
6 ampere.
you are right. I2 is basically 6 ampere. Right?
Okay, sir.
You understand, right? Like see this loop. So how is I2 flowing? I2 is flowing like this. So no current, you understand that this is open circuit. A and B are just open circuit. So no current can flow through this. So I2 is coming here. It cannot flow through this. So it has to flow like this. You understood? You understood this?
Yes, sir.
I2 has no other path. It has to flow through 6 ampere, which means that I2 is the same as 6 ampere. Did you understand? No current can flow through this, right? So I2 has to flow through 6 ampere. All right.
Okay, sir. Now clear.
So basically, I2 is just 6 ampere direct. Okay. So just rewrite the equation. Right. So 24 is equal to 9I1 minus 6 I2. I2 is 6 ampere. So 6 are 36. So you get I1 is equal to 24 plus 36 is 60. So 60 by 9 amperes. All right. So this is your I1. Okay. So this is your I1. All right.
Yes,
Okay.
sir.
So the question is, what is the value of Thevenin voltage, right? What is the value of Thevenin voltage that you will see? All right. So you know that there is no current that is flowing over here. So can you tell me what will be the value of Thevenin voltage? The voltage will be, see, there is no current that flows over here, no current that flows over here. So basically, the voltage across this, right, is Thevenin, V Thevenin, correct? So V Thevenin can be written as 6 into what?
I1 minus I2.
Correct. Directly, right? So 6 into 60 by 9 minus 6 ampere. Okay. How much are you getting?
4 volts.
Correct. You will get 4 volts. Are you understanding this, everyone? How V Thevenin is directly coming over here, right? Because no current flows through an open circuit. So obviously the voltage will be the same as voltage across 6 ohm resistor, or you can also write 24 minus 3i1. 24 minus 3i1 is equal to VThevenin. This drop 24 minus 3i1, right? Same, you will be getting the same answer, 4 volt. Is this fine with everybody? How we found out VThevenin?
Yes, sir.
Okay, so the next question is pretty simple. In the circuit of figure below, the voltage V2 is how much? Okay, this is straightforward question, right? So what is the current I? So current is basically 12 minus 8 divided by 6 plus 4, right? V by I directly. So 4 by 10.4 amperes. Okay. So V2 is how much? V2 is basically 4 into the current, correct? This is V2, right? So 4 into current, that is 4 into 4 by 10, which is how much? 1.6 volt. Is this fine? This is a straightforward direct question, right?
Yes, sir. Clear.
Okay. Okay. So this question is, yeah. So the current I in the figure below is dash. Okay. So this current. Okay. So what is this current? Right? Is the question. I think this is an application of nodal analysis. So you take this as VA, you take this as VB. Just write the nodal analysis equations, you will be getting it. Okay, we'll just do. So this is VA, this is VB. I have to find out the current I. So what is current I? Current I is basically what? In terms of VB, VB divided by 6K is your current. Agreed? I is equal to VB by 6K.
Yes,
Okay.
sir. Yes, sir.
So the first set of equations based on VA is going to be how much? VA minus 6 by 6K. I am avoiding the 6K right now. Later on, we will include that. Okay. VA minus 6. Okay, I'll just write VA minus 6 by 6K plus VA by 6K plus VA minus VB by 6K equal to 0, right? This. All right. So I can write this as 3VA minus VB minus 6 equal to 0. This is one equation. Okay. The next equation is based on VB, right? This, and then this current. Okay. That is VB minus VA by 6K, correct? Plus VB by 6K. That's what we want. And then current flowing out of VB through this, right? So this is directly 2 milliamperes, right? Equal to 0. So I can write this as how much? Minus VA, then plus 2VB plus 12 equal to 0. Right? So solve 1 and 2. You will get what is VA VB. Right? So how much are you getting for VA and VB? Anyone? So I'm getting 6 volts for VB. Okay, VA is 0 and VB is 6 volts. Okay, so VB I'm getting is 6 volts. Therefore, I is basically how much? 6 volts divided by 6K, which is basically 1 milliampere. Sorry. Is this fine with everyone? We just apply nodal analysis. Fine? Okay, so I think this was a pretty simple problem. So just apply nodal analysis, you will be getting what is I. I is basically VB by 6K. Okay. So the next question is, okay, so using Norton's theorem, the Norton's equivalent resistance Rn of the circuit in the figure below at terminal CAB is how much? Okay. So they have asked you the, sorry?
9 ohm.
So tell how you are getting 9 ohm.
5 ohm and 4 ohm in the series, and the voltage source are open.
Okay, voltage sources.
Are open.
So you tell me, so what do you do? Do you short voltage sources or open up voltage sources?
Short voltage.
Correct. So then what is the equivalent? If you short, see,
5 ohm only.
sorry. See, this is a very good question. The point is, you know that you should short voltage sources, right? So you short the voltage source. You have shorted the voltage source. Okay. So once you short the voltage source, can you tell me what will be the value of Ix? Will any current flow through the 4 ohm resistor if you short the voltage source?
No.
So first thing is you short 10 ohm, 10 volt. Okay. Therefore, entire current will flow through the shorted path. No current will flow through the 4 ohm resistor. Therefore, you will see that Ix is basically 0, right? Because you have shorted the 10 volt voltage source, Ix is basically 0. Since Ix is 0, you see 2Ix is also equal to 0, right? So which means if the current source value is 0, current source value is 0 means it is basically open, right? I can draw this as this is a short. There is no current flowing. On the left of it, I have 5 ohm and I'm telling that the value is 0. So value of 2Ix is 0 means it is open, right? Current source is open, right? So no current over here. Therefore, you get only A, B, and there is no current that flows here also. Okay. So the only resistor is 5 ohm. So R Norton is basically 5 ohm. Did you get it? Did you get this? Everyone? Simple question. Just you short voltage source, the answer is done.
Yes, sir.
Okay. Ix is 0 means 2Ix is also equal to 0, right? Okay. Okay. So
But sir,
the
when
maximum
we
power in watts
change
that the
the
active network to the left of terminal CAB can deliver to the adjustable resistor R in the figure below is dash. Okay, so we still have got 3 questions left, and I feel we will try to complete this question as soon as possible, but the next 2 questions are kind of interlinked. So if you can hang around for probably 10 minutes extra, we can complete the entire 19 questions. Okay, anyway, so this question first we will do. The max, understand that this is based on the theorem of maximum power transfer. Okay, So again, what you need to do first, we have to Thevenize it, right? That is, we have to find out what is V Thevenin, what is R Thevenin, reduce it to a network of V Thevenin, R Thevenin, and then this is your R. Am I correct? This is the theorem of maximum power transfer, right? We find out V Thevenin, R Thevenin. You simplify the entire network as V Thevenin in series with R Thevenin, and that is basically connected to your load resistance. Okay. Right? We just need to find out what is V Thevenin and R Thevenin.
Okay, sir.
Okay.
Okay, sir.
Okay. So first question is R Thevenin. So how do you find out R Thevenin? You will
15 ohm.
short the voltage source. So you short the voltage source. What is the equivalent? What is the equivalent
15 ohm.
when you see from here? 60
30
parallel
ohm.
to 60 parallel to 60 parallel to 30.
30.
How much is this? 60 parallel
15
60
ohm.
is 30. So 30 parallel 30 is going to be
15.
15 ohm. Correct?
Yes, sir.
So this is pretty simple. And what about V Thevenin? Right? So what about V Thevenin? I can take 60 and 30 in parallel, right? 60 parallel to 30 is 20 ohms. So you can redraw the circuit as 60 ohms, 90 volts, correct? And 60 parallel to 30 is going to be how much? 20 ohms, right? This is your A, this is your B. Okay. No current is obviously flowing through A, no current flows through this. So what is your voltage across 20 ohms by potential division rule, right? VAB is what? 90 into 20 by 60 plus 20. Is this fine with you? Is this correct? How much will you get? So yeah, so you get, sorry. So you get 22 point, okay. You get 22.5 volts, right? This is your V Thevenin. Is this fine with you? Simple, right? So now we have got the equivalent network, right? So this we can now write as V Thevenin, R Thevenin, RL. Okay. So the question is, what is the maximum power that is delivered to RL, right? What is the maximum power that is delivered to the load resistance? So what is the maximum power? By maximum theorem of maximum power transfer. So I can write that the power is basically I square RL. Okay. So what should be the value of RL so that I can transfer maximum power?
VTH square upon 4 RTH.
That is true. So how is that formula coming?
VTH upon RTH plus RL whole square into RL.
Correct. So I is basically VTH divided by RTH plus RL. So whole square into RL. Okay. So you know that to ensure maximum power transfer, if you kind of differentiate it, right? So let me take another slide. I think I'm going to run out of time. Just a second. Okay. So what is the maximum power? So the power is I square RL, right? So the network was something like this: VTH, RTH, RL, right? So I is basically how much? VTH by RTH plus RL, the whole square. Okay, this is your power. So in order to get maximum power, right, what should be the value of resistance? You should differentiate the power with respect to DRL, equate it to 0. It turns out that if you do this, you will find that RTH equal to RL. That is, if your load resistance is the same as your Thevenin resistance, you will be able to transfer maximum power. Okay. So if the load resistance is same as Thevenin resistance, you can transfer maximum power. Therefore, your equation simplifies to VTH square divided by 2 into RTH the whole square into RTH, right? So you will get VTH square by 4R Thevenin. This is the maximum power, okay, that can be transferred. So the maximum power that can be transferred comes when your load resistance is the same as your Thevenin resistance. All right. So this is your P max. So we found out what is V Thevenin 22.5 volt. We know what is R Thevenin 15 ohm. So from this you can find out what is P max, right? So P max is basically 22.5 square divided by 4 into 15, which is how much? I think you should get somewhere around 8.44 watt. Is this fine? This game of maximum power transfer. Okay. Yeah. So this is the maximum power that can be transferred. Okay, so we still have one more question left. Should I go through it or like should we go through in the next week? You can tell. Can I go through it or should we go through in the next week only?
Go through it.
We can go through, right? Okay. Yeah. So the resistance should be connected across terminal AB for the circuit shown in figure below, which will draw maximum power from the rest of the circuit. The resistance required for maximum power transfer is dash. Again, you know that the resistance for maximum power transfer means RL should be same as R Thevenin. So we have to find out. Oh, we have to find out the Thevenin. Okay, so how do you find it out, right? So can someone tell, seeing this circuit, how can you simplify? How will we find out R Thevenin? Any formation over here that you can simplify? So this
Start
is
to delta transformation. Start to
so
delta
this is in delta or star,
delta.
right? So
Delta.
delta will convert to star. Same over here, right? This we will convert from delta to star. So you tell me, if you convert from delta to star, what will happen to the equivalent resistance? All resistance are 30, 30, 30. So if I make it to star, right, that is something like this, correct? Same over here. So what will happen to the resistances? Will it increase or decrease for star? Directly by inspection, can you tell? Okay, so let me teach you a trick, right? So you are having something like this.
So
Here
all will
there
be
is
48 by 3.
all will be
48 by
scaled by
3.
3. Ah,
6 upon
so it will be divided by 3. So you are having resistance over here, resistance over here, resistance over here. So this resistance, right, the resistance in dark blue, that will be the multiplication of the adjacent two resistors and divided by the summation of all three. Okay. For instance, this particular resistor, right, it will be multiplication of this and this resistor divided by summation of all. Okay. So yeah. So if I can write about this, it will be this multiplied by this divided by summation of everything. Okay. Okay, fine. So we are already short of time, so I will erase this. We will just do start to delta transformation. So what you will end up with is basically 60 volts, 10 ohm, all right? Am I still audible? Excuse me, hello?
Yes, sir.
Okay.
Yes, sir,
So,
you're audible.
okay, thanks. So now we have converted from star to delta, right? So this particular resistance will be how much? 30 into 30 divided by 30 plus 30 plus 30, which is basically 30 by 3. We'll be getting 10 ohm over here. Okay, from the terminal of 20 ohm, you see there is this particular resistance, right? So again, you'll be getting 10 ohm over here, right? So this and this are meeting. Okay. Okay. And from here, there is this resistance, which is again 10 ohm. Okay. Similarly, if you go down, right, there is a 6 ohm resistor, and from 6 ohm, there is this resistor, right? So what will be that resistor? 48 by 3. Okay, 48 by 3 is 16 ohms. Okay, same again, from 20 ohm, you are again having another resistor, which is again 48 by 3, which is 16, which connects to this, correct? So I will again draw 16 ohm. Okay. And finally, from here, you are having another 16 ohm. Okay. Did you get this? Is it fine till this point? So is this fine? So this is the equivalent star of the delta that we did. Same over here, 16, 16 and 16. Is this fine? Are you understanding this transformation and the connection, everyone?
Yes, sir.
If you didn't get, please tell me
Yes,
now.
sir.
Okay. So let me take another color and so just we will simplify this a little. So 60 volts and you are having 10 and 10 in series 20 ohm and over here you are already having 20 ohm. Okay. So from 20 ohm, what you are having is two branches. One is 10 ohm and the other one is 16 ohms. Okay. This is 10 ohm and bottom you are having 6 plus 16, 22 ohms. Just a simplification of the other above circuit, nothing else. 16 ohms, 35, 15, 35. Is this fine with everybody, this particular circuit? Okay. So now we will go ahead with the problem. Okay, there was a reason I didn't remove this 60 volts. Now the question is that what is the resistance? So what is the Thevenin equivalent resistance? Right? To find out the Thevenin equivalent resistance, we short the voltage sources, right? We short the independent voltage sources. So 60 volts is gone out of picture now, right? Probably I will need to redraw this. So 60 volts is shorted, therefore what you get is so 60 volts is shorted and then 20 and 20. So you have 20 over here, you have a 20 over here, and then you have a 22. Okay. And then 10 and 16. 10, 16. Um, ten and 16. So this is here, this is here. So how will you find out the equivalent from this network? How can you find out the equivalent of this network? Okay, so I will redraw this. Okay, I'll just redraw this a little, right? So 20, right? And I'm having a 20. Okay, So this 10 ohm, I'm redrawing it vertically. Okay. This is 10, right? And I have 10 ohm. Okay. And this 16 ohm, again, I am redrawing it vertically. I am having 16 ohm. So there is just a 22 ohm, which is between this to this. And again, I'm having 16 ohm. Are you understanding this, everyone? How this particular step came about from here to here? Are you understanding?
Yes.
See, you understand, you realize that this 20 ohm, 16 ohm, and 22 ohm is in a delta connection. Okay. Or you can also do the same for the above 20, 22, and 10. It's also in delta connection. You can do either way. Are you understanding this? Okay. So this basically delta connection. Please, if you solve more problems, you can easily find out what are delta and star connections. Okay. Seeing this figure, it seems like, okay, it's apparently not visible at all. Okay. But point is, if you just rearrange a little, you are directly able to see the delta connection, right? So again, this is a delta connection. Therefore, you have to convert it into star. You do this, the answer is quite near. Okay. So we will just redraw this again. 20 ohm, right? So, so what is this resistance? This resistance will be basically 22 into 20 divided by 22 plus 20 plus 16. Okay. And you are having 10 ohm over here. This is 10 ohm. Okay. Let me redraw. So what is this resistance? It will be 20 into 22 divided by 20 plus 22 plus 16. This resistance will be 22 into 16 divided by same denominator. Okay. And similarly, this will be 20 into 16 divided by this. Okay. So if you do the math, you should be getting 7.59 ohm and 5.52 ohm and 6.07 ohms. Okay. So now this circuit is equivalent to simplify. It's simple, right? Easy to simplify, right? Everyone, are you here with me? Is this fine? Or is it difficult?
It's fine, sir.
Okay. So just now I think it's directly you can simplify by inspection. 20 and 7.59 in series. So this is 27.59, right? And then 10 and 5.52 in series. So 15.52. Okay. And you have 6.07 and 16 ohm in series. Therefore, you get 22.07 and you have 10 ohm. So if you simplify this, the R equivalent that you will be getting is around 42 ohms. Okay. Is this fine? Is this fine with everyone? R equivalent is 42 ohms. Okay. We just use star delta transformation. All right. Okay, so the next question is to find out the maximum power transfer for which you require P max is equal to V Thevenin square by 4 R Thevenin. So you have to find out what is V Thevenin. Okay, so we are already above time. We will continue this question in the next class, but you can also try out. Okay, the same circuit in the simplified circuit, right? In this circuit, you try to find out what is the V Thevenin, right? If you find out what is V Thevenin, you should be able to find out the maximum power transfer. Okay. Okay, I think we are way past the finish time, so I think we have to stop over here. Thanks everyone for attending, and we will continue in the next class. Okay. So yeah, we will. I will start off with this problem again. In case you did not get this, we will go through this problem and then continue with the rest of the problems. So any feedback? Do we need to go a little faster or little slower, or any feedback, or is this pace fine? Yeah, so see you on Tuesday. Okay. So this tutorial session will be conducted every Tuesday from 6 to 8 in the evening. Alright. Okay. Okay, then we will conclude for the day today. And thanks everyone for attending and have a great week ahead. Okay. We will continue with the same question from the next class. Right? Okay, everyone. Bye bye. Good night.